Hello everyone, welcome to this presentation which concerns the application of industrial symbiosis in this framework of the African cities of the future. So industrial symbiosis concerns the reuse of waste materials and byproducts from some process. So if there's a process that's generating residue or wastage, then instead of diverting that to disposal or landfill, we reuse that in some other industry that may have use for those materials. So this is carried out successfully in some countries like Sweden. The graphic here shows the kind of integration that's achieved there. And this is also happening in South Africa at the moment to some extent, but we believe through computing methods that this can be developed further. So that's largely what this presentation is about. And to describe the present state of industrial symbiosis in the country, currently we have this kind of manual matching going on. So there are partners that are collaborating through these association groups and through speed dating events, where largely two partners may identify a waste stream that can be used, and so they form that symbiosis relationship. There does exist some software, but it's relatively high in cost and offers a relatively low level of integration. And in this project, we are investigating the reasons for the low level of integration, some of the challenges facing industrial symbiosis, and they're listed here. So number one, the first challenge to industrial symbiosis is that you need many participants involved in industrial symbiosis for it to work. So you need some kind of common platform of communication among these interested parties. And an important part of that is that the partners must be willing to disperse information. So some of the best opportunities for industrial symbiosis occur where we may have controversial waste streams. So we need partners that are willing to disclose information about these waste streams. And then furthermore, it may be the case that a potential recipient of a chemical stream may require those chemicals in a specific form, for example, solid particles and things like that. And of course, there are multiple technologies available that can help translate our chemical streams into these different physical and sometimes even chemically alternative forms. But of course, evaluating all these multiple technologies rapidly goes beyond the human ability to do that. Then, of course, the recipients also require some guarantees about the chemical form that's coming from what's largely a waste stream. So they require frequent testing and sometimes what they call accreditation about the nature of that stream. So they need some guarantees about the type of chemical coming in. Then, of course, transportation costs may be significant if we are talking about inter-process and inter-industry collaboration. So the transportation costs of chemicals can be quite high when doing it this way. And then, well, the last one is not so much a challenge as an opportunity that if we consider the purpose of a chemical, we might find more candidates for accomplishing that same purpose. So functional substitution yields better opportunities for integration. So looking through each of these challenges, we are proposing in this project, which we've called the Chemicals Without Borders project, the development of a cloud-based system, which of course serves as a place where members can register and disclose their raw materials usage and the sorts of byproducts and waste materials that they generate. I'm not going to go through these particular slides in detail to keep this talk under 10 minutes, but please pose your questions in the comment section below. So the first thing is, in terms of communication, a cloud-based platform. Then secondly, in terms of managing the disclosure, so the major challenge of disclosing potentially controversial waste streams it can pose a serious challenge to to accomplishing industrial symbiosis. So, of course, with an online system, however, you can manage the disclosure better. So you can apply different models of disclosure. So if it's a non-controversial waste stream, of course, that can be that can fall under a public model. On the other hand, if it is a controversial waste stream, but still the user wants exposure to potential users of that stream, alternative uses for that stream, then in the system, the user could specify that only potential users of those chemical fractions should be alerted to the presence. So that's one possibility. Another possibility is that the user might say, well, I don't want this exposed to whole categories of people, but there are specific companies that I would like to be aware of this waste stream, and so disclose only to companies X, Y, and Z. So that's another possibility. So through an online system, you can manage the disclosure of and the data concerning these waste streams. A third solution to these challenges that have been mentioned in terms of processing is that through computing support, we can, of course, evaluate all these different technologies and look at what new opportunities become exposed when we consider the influence of adding technology. So we could propose that a particular technology can convert one chemical form to another, and hence it becomes available to other recipients that may not have been thought of before. And of course, in that situation, there must be some negotiation about who will carry the costs of that chemical conversion. So that's another possibility that's also integrated into this Chemicals Without Borders project. Then, of course, the accreditation and testing of these chemical streams, that, as you know, coming from academia, I would, of course, suggest that the universities have a strong role to play in these things. So there are, of course, labs at all the universities that can assist with this. But, of course, through the system also, a user may register his laboratory and make it available for testing and so on. So you can use the platform for growing the network of testers and experimentalists who wish to support this industrial symbiosis concept. The cost of transportation we handle in a kind of simple way. So we had mentioned earlier about the conversion of chemicals from one type to another. We can also classify the geolocation as an attribute of a chemical stream. So we can model transportation as a process which converts a chemical in one geolocation to the same chemical in a different geolocation. So this is how we integrate transportation into our framework. We just model it as a different kind of chemical process. So of course this can pose a significant challenge because of the high costs of transportation of chemicals. But there's a relatively easy way to evaluate the costs of transportation and the influence that has on the symbiosis opportunities. Functional substitution, we've mentioned this is more about also an opportunity for increasing symbiosis options. So this is the concept where a user may specify what he wants to accomplish with a chemical rather than what that chemical should be. So for example, a user may specify, I want silica particles of 50 microns, when actually what that user needs is an inert solid particle with a high surface area. So if that's the case, if a user can put the time into specifying the functional needs rather than the presumed chemical needs, then of course there are many, many more possibilities for industrial symbiosis. So in conclusion, there are solutions to the major challenges of accomplishing industrial symbiosis. So we are offering these solutions through the Chemicals Without Borders aspect, which is, you could say, the chemicals side of this African Cities of the Future framework. So for more information about joining the system, please contact us. So our email addresses are there. So Christina Troyes is the Dean of Engineering, and that's me, Randi Rawatlal. So please write to us if you are interested in joining the program. Thank you.